Hi everyone, welcome to class number 4, and we're picking up from where we left at the end of class number 3, which is our failed attempt to create some ceramic tiles. And here are some more examples of my my attempt to create nice ceramic tiles. This one I love especially. So all of these are seamlessly tileable, but they're useless because they look weird. And as you remember, we said that we need to be able to guide the generation so that we can get straight, normal looking tiles. So today we're going to look at some control nets. So let's go into the workflow editor and we're going to bring in an image. That will be our guide. So it's not called load image here in Invoke AI. It's called image primitive. So let's search for that. And that will allow us to load an image. I'm going to select a pre-existing texture. It's actually not even a texture of ceramic tiles. It's actually wood planks, but that's fine because what we need really is a guide for the shape of the tiles. And I like this pattern. So we can use anything, and that's the good thing here. You can use a wood texture to create ceramic textures. You can use a metal texture to create whatever. It's really interchangeable. We're talking about patterns here. So control nets are usually, they have two components. There is the control net itself and the preprocessor. The preprocessor enables you to extract a certain information from an image that will be used by the control net. So in the next classes in the course, we're going to look at control nets that extract depth information and or normal information, normal facing direction. Here we're of course more interested in the lines and the patterns. So there are a few edge detection algorithms that we can use, and they do things a little bit differently. So if we go and type edge, the first one we want to look at is the canny edge detection, and there is a control net called canny. And by the way, this is not specific just to Invoke AI. You can get the same type of control nets, sometimes just slightly different in ConfUI. So we're going to connect our image here. And to be able to see how and what exactly the canny edge detection is detecting and what it will output to the control net, we can just enable save to gallery. So let's run it by the default settings. And it's very fast. This is the result. So what you see is that it's basically looking at all the detail and creating a very, very, very busy kind of image pattern, trying to get every detail in there. You have some control over how much detail it will get. So basically, the lower you go here in the threshold, the more detail you'll get. So if we go down to say 0, so 0 to 200, what we'll get is even busier. Conversely, we can go higher up to get less of the high frequency detail and more of the low frequency detail. So let's change the 200 to say 300. And let's start this with 250. So that's the highest is 255. So let's start this with 200 to 255. And you see that now we got a much less busy pattern. Still, the edge detection is good when you want to get a lot of detail from the image. In our case, it may not be the right one to use since we want to create kind of smooth-ish tiles using this pattern. So we're not really interested in all the fine detail. But for other types of textures, sometimes, for example, if it's a stone wall, you may want to get all that detail and implement it and guide the generation with it. So that's one option, the canny edge detection. So let's delete this one and search for edge again. And now you see something called HED, edge detection. This is a soft edge detection, so it's slightly different from canny. Let's give it a try. And what we get here is wider, softer edges. a lot less detail. This could be a lot more helpful, especially to get the the gaps between the tiles. We can also switch this to a scribble mode, and that will give us something like this, which basically, well, it looks like a scribble. So the scribble control net allows you, if you're not using the preprocessor, for example, you can literally scribble, using any kind of simple paint program, scribble some outlines and feed that as a control net to guide the generation. We're going to look at this probably later on. Again, for this purpose, that option is not the most helpful. This will not help us much in creating the kind of tiles we want, but I wanted to show this one to you as well. Now, the one control net preprocessor that I think would be the most useful for us in this specific case is the line art control net. So we want to type in line, and what we're looking for is the line art edge detection. Let's connect it and save to gallery. Now, this is much better in terms of what we need for this specific texture. It gets the straight lines very, very clearly. It's getting a lot of the fine detail here, which we may not need. In generally, it's a lot less busy. We have the option to go into coarse mode here, which will remove some of the finer detail, which may be even better for us. So yeah. So what we're going to do next is we're going to go back to the script that we created in the previous class and start implementing some of these control nets and create a system where we can basically switch or mix between different control nets to get exactly what we want. So this is the workflow that we saved in the previous class. And let's first bring the image. So we need an image primitive. And load that same texture. And first, we're going to bring in the line preprocessor. So line art edge detection. Connect the image. Let's move it up a little bit. Now, this needs to feed into a control net. So let's bring in a control net node. And again, we want a control net for SD 1.5 and connect the image. And the control net, let's just move all these a little more to the left. The control net will feed into the control input here in the denoise. And we have to select the type of control net. So since we're doing line art here, we need to select the line art option. So we do want to use the condensed list of parameters that we started creating here on the left in the previous class. So we can add some more parameters now that we're adding some control nets. So let's click on the little pencil button here to edit this panel. And the first thing we want to add probably is an image input right there to the panel. So now whenever you work, even if you're in image view or in any other mode, you can simply drag an image from your images here and input it here, so you don't have to go to the node and load another image. So, and we can call this control net image. Nothing here that we need to load. Let's just set this to coarse, since we saw that it will be better to use a coarse for this texture. And here, we're not going to change this control net because it's always going to be hardwired to the line art one. But we do have these options here. So we have the overall control weight, which will allow us to balance between different control nets by changing their weights, their relative weights. And we have a beginning step percent and an end step percent. And these two parameters are very important to kind of fine tune the effect of the control net. Obviously, the lower the end step percent is, the less it's going to try and read the small detail and apply that to the image. So let's add the control weight, the beginning and ending. And it doesn't specify what this relates to, which control net. If we're going to add more than one, then it's going to be hard to know. So we should probably change this to line art weight, and this to line art start. We don't have to say %, and line art end. Now, another parameter here that you see is the control mode. It could be balanced between the control net and the prompt. It could be more prompt, more control, or unbalanced, which I'm not even sure what that means. But let's keep it at balanced for now. And let's do a test. So we're going to leave the parameter here at full. So the weight is 1, and it goes from 0 to 1 in terms of the percentage. 1 means 100% actually for the percentage. And let's see what we're getting as a result here. So this is already a lot better than the tiles that we got previously, but it's definitely looking too much like wood rather than ceramic tiles. So we should probably reduce both the weight of the control net, but also maybe the end %, because that is bringing all the fine detail that we probably don't want. So we can do it here. This is our condensed list when you come out of the edit mode. So it's much more convenient. So let's change the overall weight to 0.5. And let's change this to, say, 0.5 also, the end %. And let's see what we're getting now. Okay, so now we're getting something that looks a lot more like ceramic tiles. We still see some of the wood patterns in there, but it's much closer. So let's see what happens if we reduce the amount even more. Let's also add something to the prompt to kind of pull it towards more, let's say, smoother tiles. So let's say smooth, shiny ceramic tiles. Let's change the end % to 0.3. Let's see what we're getting. Yeah, so that's a lot better still. So as you can see, between balancing the control net and the prompt itself, you can use the control net in this case to get you straight, normal looking tiles without getting all the fine detail that you're getting from a different texture. And that allows you to use different textures that are not necessarily related just for their patterns to apply into other textures. So we're using a wood texture to create ceramic tiles in this case. But now we want, since we're building a tool that we want it to be flexible and allow us to generate different types of textures, we probably should add more control nets in the tool already so that we can have a selection and we can kind of change the balance between the control nets depending on the textures we want to achieve. So back to the workflow editor, and we're going to use the same image, but we need a different type of edge detection, right? We want to add the canny edge detection. And control the connect the image to it. Now we can copy this and paste, but since this already has those names, line art weight and all, maybe it's better to put a new one here, a new control net node, just so that we don't copy these. And connect the image. Now we can't connect two outputs into one input here, so we need to combine these two control net. Invoke AI has a node called collect. There's actually a few types of collect. There's some that are specified for certain type of nodes, but there's none specified for ControlNet. So we're just going to use the generic collect. Here it is. And this one accepts multiple inputs. So we connect both of these to the input here. And then the whole collection goes into control, but we need to first delete this line. All right. Now we can add the parameters of the second control net, same as we did before. So we have them nicely laid out here. So this time I think we probably want to use the low and high threshold because as you remember, it really affects how much the canny grabs fine detail versus rough detail. So let's just add these two, 1 and 2. And here, of course, we need to select canny. So hard edge detection, canny, and we probably want to add the control weight, the beginning percent, and end percent. And then, of course, you can go here and add to the name, let's say, canny. Now, for some reason that I don't quite understand, in the control model list, there's actually 2 times that hard edge detection appears, one at the very top and another time towards the bottom. If you select the one at the bottom right here, it's not going to work. So make sure you select the one at the top. So now let's give it a try. So we can switch this from the edit mode to the parameter mode. And go back to image viewer here. And what we'll do is we're going to change the weight. So we're going to zero out line art. So we're not going to use the line art one. And instead keep only the canny at 1. And let's see what we're getting. All right. So obviously we're back to like a very hard wood looking floor. Definitely not ceramic, but that's just because canny, as you know, gives us all these fine detail. So that's an example. Doesn't work for our ceramic tiles, but let's take a look at another texture that we want to create using the same tool that we just built. So let's go into our assets folder. This is where any image that you bring as an asset shows up, and we can load a new image here. And let's go now back to our stone wall option, and let's select this texture that I got here, and you can use any type of texture that you want to try it out for yourself. This has some nice patterns there, also has some fine detail. So now we can just drag this over to our image input. And if you look at the workflow, you can see that we switched the input. And that's basically it. Now, of course, let's change the prompt and say rough old stone wall moss. I like moss. And let's first, and you know what? Right now, we're not actually seeing what the preprocessors are creating. So the line art edge detection and the canny edge detection, they each create an image that feeds into the control net. And we want to be able to actually see the images that they create. So it gives us an idea how we want to balance the weight between them. So it's easy. Let's just click Save to Gallery for each one of these preprocessors. Now, the next time we do a run, the images will appear here too. So we have the prompt, we have this, and let's start with line art. So we're going to put line art at 1 and the canny control weight to 0. So we're only doing line art. So first we got this really nice stone wall with, I requested some moss and it really did it well. I like Analog Madness. It's also fully tileable, as we know already. Here we see the results of both preprocessors. So this is the line art, which gives us the nice edges between the stones. And this is the canny, which gives us a lot of noise. So let's say we want to roughen up the stones and use also the canny in there because it was turned off. But maybe we can bring the low threshold a bit higher. Let's say, let's do 160. So maybe we'll get a bit of a less noisy result. Now, if you're not making any changes in a preprocessor, then the image will not appear again. It will show the same image, which is good because we don't want to accumulate too many images here. And now let's set them both to equal weights. And let's see what we get this time. All right, so we got a new texture. Obviously, I didn't set the noise seed to a constant number, so it's also changing the seed every time. So we're not really comparing apples to apples. We can go ahead and do that. But this result is enough to give us some feeling of like all these fine texture that we're getting here from the Canny preprocessor appears more than this, where this created more of a natural kind of stone texture, whereas this one really tried to accommodate that canny. So depending on your needs, depending on the texture you're doing, you can add as many kind of line detection algorithms as you want and simply switch between them. You can also, of course, change the start and end percentage, which we haven't even done. And in a single tool, you get a lot of flexibility. You get very easy creation of seamlessly tileable textures. And overall, here's an example of extremely useful and pretty easy to create tool using AI. So before we go back to ComfyUI in the next class, I wanted to talk a little bit about SDXL. You remember that we loaded SDXL Turbo for ComfyUI in the second class. And here I want to refer to another SDXL model called Juggernaut. It's very popular, also for photoreal imagery. You can download it. You don't even need to go anywhere. You can get it right here. If you go to the models page and starter models and look for the SDXL models, it will be right here. Just click on it. I've already got it installed, of course. And the interesting thing about SDXL models is that they use prompts already divided into two parts. You see that we have two outputs, clip 1 and clip 2, and these are connected both to the positive prompt and the negative prompt. So this time I use the prompt SDXL to get a different node. So the idea is that you separate, kind of like we did with a texture tool that we've built, the main prompt in the first and the style in the second section here. Now, SDXL doesn't really use negative prompting, so I don't even know why the denoise has it. I assume that because it's also the same denoise used for SD 1.5, it has a negative conditioning. You don't have to put anything here, but you do need to connect something to the negative conditioning. Other than that, everything is very similar, but Juggernaut and other SDXL models are they're very sensitive to the style parameters. And you see that I kept the same jungle prompt that we used in the second class, but here added photorealistic, 4K, and photo. Now, 4K doesn't mean that we want to output a 4K image. When you put 4K, it's another indication in the prompt for the model to kind of dig out those 4K images that it may have been trained on. Usually it's something you put in there to prompt for better quality. And yeah, let's run this one, see what we're getting. Yeah, so we got a pretty nice image. The SDXL models are really good on detail. They're not always, their output is not always as photoreal as some of the models that we've been using. But let's now just change the style here a little bit, and let's add shallow depth of field. Let's see how this affects the output. So you see right away how SDXL is sensitive to the style part of the prompt, and it really went, from like a wide image to a macro photo, just like you would expect it to do if you're asking for a shallow depth of field. So I recommend playing a little bit with the SDXL models. We can also take a look at the SDXL Turbo when we go back to Comfy, because that one, its advantage is that you can generate images with only one iteration as opposed to 25 or 30. So thank you, and I'll see you all in the next class.